Welcome everybody. It is office hours time again. In fact, I think we could probably, as they say in the gadget world, we could call this Techtober in terms of the amount of tech that's going on. Because, oh my goodness, if you haven't been webinared into submission yet, you're a better man, woman, child, person than me. Because the reason I had to defer office hours last week was because I had 3 webinars to give. I've already given 2 this week, got another one coming up, I think early next week, etc. So yes, October is a big month, and I think it'll probably stay the same until the end of the year. So just to reiterate, apologies for deferring office hours last month or last week. Yeah, I was just snowed under with clashes in timetable. But thank you all for attending. Let's just get stuck into it. Let's share the screen and we'll get going. Okay, can you sing out if you can't hear me well? Sing out if you can't see those slides. A quick check of the chat line, make sure, nope, it's all good. Okay. For those who are regulars in office hours, bear with me, it'll be the same few little sets of slides just for those that are new. Getting in touch with me is easy. Linktree/Connor. That's one simple link to remember. That way you can get me on Twitter, you can get me on Facebook, you can get me on my blog, Instagram, you name it, you can get me on Linktree/Connor. Yeah, please follow me on Twitter. That's probably the easiest way to have nice, easy conversational tech talks. As I always say, do not adjust your set. The slide content will be sort of shuffled down to the left. That's because when we turn this into a YouTube video, we'll be putting the webcam stuff at the top right, and therefore it'll all fit nicely together and nothing gets lost. Some bits and pieces. What's been happening? As I suggested, Techtober is just an insane amount of time for Oracle professionals. This one's currently, hopefully you're all in amongst it. This is, you could call this one of my homegrown conferences, one that's actually run out of Australia by a good friend of mine, Francisco Munoz-Alvarez. So this one's currently, it's been running all week and it runs all next week as well. On the 30th, if you have any interest in partitioning, I'll be giving a talk on some of the more interesting improvements that came to partitioning. I used to do a lot of partitioning 101 talks, but this one's more of all the stuff that come along after the basics of partitioning came along. But there's a swag of great content in there. And once again, it's being all recorded. So if it's not your time zone, you'll be able to get access to it, but you do need to register. It's free, by the way. On the 29th, I'll be speaking to the Swiss Oracle user group about some hints and tips that I've picked up over, I hate to say it, 25 plus years of working with Oracle technology. Just things I thought I'd share rather than people having to relearn and reinvent the wheel. Then the week after that, this is, I suppose, one of the joys, one of the benefits of the virtual world we currently live in is the odds of me getting to the East Coast of USA Oracle User Group Conference. Lovely people over there. Linda has always reached out to me every year saying, please come along. And I've always wanted to go, but let's face it, it's 30 hours and several flights away. But this year, whilst not ideal, I can do it virtually. So I'll be speaking at the East Coast Oracle event. Then a week after that, we've got the Australian Oracle User Group Conference. So I'll be doing some couple of talks there as well. Once again, they'll be virtual and they'll be recorded. So if you're not in this time zone, you'll be able to catch them as well. Whew. I've actually just finished an event held by the Spanish Oracle User Group. I want to talk just briefly about this one, even though it's done, because it was just an interesting way of, as I'm sure many of you are sort of maybe feeling that, there's been a lot of webinars lately, but theirs was different. Theirs was actually a virtual world. You actually got into, you had an avatar and you went and you sort of did a virtual equivalent of attending a conference. You actually sat in a seat and you watched talks, and then you could talk to other people. In fact, you can probably see just at the right there, Ludo DBA, that's Ludovico, one of the ACE directors. He just happened to be sitting next to me in the opening auditorium. And the way it worked is you literally walked around in this auditorium. I captured a bit of video here. That's my avatar. But you would actually walk around. If you were presenting, you could wave at people. You'd clap if you were happy with someone's talk. And as a presenter, you would stand at the lectern and sort of flick through your slides, etc. There's a few technical challenges, a few limitations, but in terms of just a different format, something to make it, to keep things a little bit edgy. I thought this was a real credit to them. It's very brave to go out and try something brand new. Since I'm talking virtual, my standard public service announcement for office hours every month is, this is just a terrifying map. I get it from John Hopkins every once in a while. But all I'm saying is, especially now we start hearing things about second outbreaks and stuff like that. And in Australia, we've had another big lockdown in Victoria. As I said, we are a community. Yes, we're a professional community, but I'd like to still think that we're all friends and all good colleagues. So please, follow your local bylaws, stay safe, because one day when we get out of this, I'd love to, be sharing a beer with you face to face, not just over a virtual event. And finally, the big piece of news, literally from last night, great timing. The latest and greatest release of Apex has just gone general availability. It's been available on apex.oracle.com for a few weeks now, but yes, now you can download it, you can install it. I think coming up after this very office hours is an Apex one covering the new release. So, literally at 1 hour on the dot, just boot me and head over to the Apex one because it's a very cool release. I know we're getting slammed. We get Zoom coming out of our proverbials, but don't worry, this session is recorded. And if you can't bear watching an hour of video, rest assured this whole session will be carved up into more bite-sized chunks, and you'll be able to get them on my YouTube channel in the coming weeks once I get a moment free from webinars to actually do some video editing. But based on the Spanish Oracle user group, if you're fed up with Zoom or fed up with webinars, if you have any ideas, any cool ideas you have that would basically breathe more life into the virtual world we live in. The Spanish user group did a virtual world entirely, but whether it's a change to the webinar format or just a casual chat, or not just for office hours, but for anything. If you have ideas for how you can invigorate and keep our virtual platforms energized, please throw me a DM, throw it on the chat line. Now I'm hoping is that someone's got an idea. Someone just said they like this. But as I said, throw us a bone, as they say. Throw me a bone, we say in Australia. Like, help us out here. We would love to have your ideas for how to actually, improve upon these things. I didn't put a slide in this. One thing that people often forget is if you want a office hour style session where we just talk about topics at your own customer site, i.e. just a webinar just for you on site, and your developers or your managers or whoever would be interested in Oracle Tech, just reach out to us. That's something that we do. We don't charge for that. We just try to organize it around our time slot and availability. But it's just part of the service of being in the advocacy team. So we're happy to do these things in a more private and more targeted set of topics should you need so. Okie dokie. This session, geez, that guy rants and raves and rambles on a bit, doesn't he? This session, we'll try cover handling large data maintenance whilst avoiding outages. This one was from the previous office hour session. We never got onto it. Standard edition licensing. The scheduler, the really cool Oracle database scheduler, running things when it's not meant to. Serializing versus concurrency. That's a fairly vacuous topic there, but it'll be probably better explained when I get to it. It's about a particular customer having a problem in a very high-end, high transaction rate environment. And the last one, if we get to it, will be the hacken factor. Once again, if you've never heard that term before, you've got a treat in store. Let's get straight into it. Quick drink. Online data loading. Perhaps not a good title there because I would imagine all data loading is online, but the description will perhaps help us out here. We have a large 100 million row table and we modify millions of rows of this every day. There's more detail obviously behind that's provided here, but they were literally updating almost half the rows every single day. During this update, queries to this table are incredibly slow or they time out. So they tried an alternative, which was rather than update millions of rows, they truncated and reloaded the table. But obviously the moment you truncate the table, everyone's queries start going horribly wrong. They're sort of stuck between a rock and a hard place. What are some of the options? And I've mentioned in previous videos that the dealing of what we call the cost of undoing data to get a read consistent view. That's possibly what this customer was encountering. It could have just been their server was overwhelmed. Either way, we're looking for mechanisms by which we can reduce the load and get a better result here for our customer. So let's use an entirely demo-based system to describe this problem, and we'll walk through what the problem is and recreate that, and then we'll walk through maybe some potential solutions. Seeing out if anyone can't see that, I think we've got a big enough font here that hopefully it's all readable. So my 100 million row table is going to be only a copy of DBA objects. It's going to be big enough for our needs. It's only about 80,000 rows, but that will be fine. I'm putting an index on the owner column just to mimic, a typical environment where we have various subordinate objects sitting behind a table. I'm going to simulate now what happens when you do large data maintenance while people are actively querying the table. Now, rather than have 25 windows on the screen and you getting lost, and more importantly, me getting lost, I'll do it in the same session by opening up some ref cursors. So here I'm opening up a ref cursor, select count status from the table called T. So that cursor is opened before I do my data maintenance. This is simulating someone actively running queries from other sessions while data maintenance goes on. I can print that out. This query has been opened and it's been run. So this is the perfect scenario where there's no data maintenance going on, and we can see what it costs to run that particular query. It is what? 13,000, I think that's microseconds. So 13 milliseconds of CPU time, and we did 1,333 buffer gets, which is fine. It's about that many bytes in the index to read the table. It's obviously sort of small table. Let's open another ref cursor now. It's actually the exact same query, and now we'll throw some data maintenance concurrently going on at the same time. So here's my data maintenance. It's just a PL SQL block. We're updating the object ID, updating the owner, updating the created, just changing or touching, in this case, every single row in the table. However, we opened that ref cursor before this data maintenance went on, simulating an actively running query while we do data maintenance, and therefore, when we actually fetch from this cursor, we actually had to provide a read consistent view and undo all those changes. So the result still comes out the same, still 52,000 rows. But instead of 13 milliseconds of CPU, now it's 42 milliseconds of CPU. For a tiny table, that difference is obviously negligible, but in terms of magnitude, that's a 3 times degradation. We've gone from 13 to 42 milliseconds. It's 3 times more expensive. And instead of 1,300 buffer gets, we've now got 55,000 buffer gets. You can start to see the very rapid escalation in costs in running queries while you're doing large data maintenance activities. So this is quite possibly the cause that this customer is having all these problems in terms of their queries either slowing down or timing out. They just have to do that much more work. Let's open up a brand new cursor now, which is after the data maintenance. And now we're going to simulate the other thing this customer tried. That is, what happens if we just truncate and reload the data and therefore avoid all that costs of dynamically changing lots of rows? They're generally very inefficient things in terms of redo and undo. I open up the cursor, I truncate the table, and therefore I reload the table. This is the direct path mechanism to reduce the window during which data maintenance occurs. We make the data maintenance operations faster. Therefore, the chances of queries being in this window are much lower. But because I've opened a ref cursor, we actually do have one in this window. Now when I'm trying to do a query, I get object no longer exists. And that's what a truncate has done. A truncate literally rips a segment out from the data file, so to speak, and simply blows it away. It doesn't really have to do anything, but that object is gone. When you truncate a segment, that segment's thrown away. When it's repopulated, you actually get a brand new segment. It has a brand new data object ID in user objects. So when I tried to fetch from this cursor, which was opened, it says, what you're trying to fetch from no longer exists. And this is the other problem that they were having. ORA 8103 normally means you're moving a segment around while queries are trying to access it. The most common ones are obviously truncate, drop, and also things like exchange partition, things along those lines where things are being shuffled around and queries can't complete successfully. So what are we going to do? So far, I've demonstrated how it's going to kill you if you do online data maintenance, how it's going to kill you if you do truncate and direct load insert. What have we achieved? Let's look at options we can now explore to improve upon this. So I'm going to create a new table called T1. It's just the same as T. It's a brand new copy of DBA objects with the same index. Now I'm going to create a view on top of T1. I'm going to call it user data. And this is the thing that I'm going to give to my user community. This is the object they're going to be able to query. They're never going to see T1. I would have that in a different schema. They wouldn't get grants on it. They have to access the data through view user data. I'm going to open up a cursor as before. So this is a simulation of our actively running query. It's already been opened. Now, rather than go and do data maintenance against table T1, where people are actively querying it, I'm going to create a copy of T1, in this case it's table T2, and do the data maintenance on that one. In this case, I've just done a very, very simple one. I've set the status column to null. So that query doing count status would actually return 0 if I queried T2. I'm going to put an index on T2 so it looks exactly the same as T1. And now I'm going to replace my view. Now this is interesting because I have an open active query querying the user data view when it used to be defined as select star from T1. And I've just come along now and just ripped the guts out of that and pointed it to T2. Let's see what happens. I print out that ref cursor, which simply said, which was originally when it was opened, was pointing to table T1. And guess what? It works fine. The reason it works fine is I've done nothing to T1. I haven't truncated it. I haven't changed anything about it. It's nice and snappy and efficient because T1 is unchanged by this operation. It was T2, which was a copy of T1, which has done all the heavy lifting. If I now open that same ref cursor, but obviously now after the data maintenance has occurred and the view has been pointed elsewhere back to T2, now when I open up a ref cursor and print it out, I get the result now that I've done my data maintenance. Remember, I set the status to null, which means count of status would return a count of 0. But notice that at no time did any errors occur. No one got object no longer exists, and there was no huge undo required because queries that were in flight were accessing T1, and queries that basically came along after the data maintenance had no idea that they were now pointing at a brand new copy of the table, T2. Obviously, this can only really be done if you have either a read-only or very nearly read-only copy of the table. If it's basically, like in a data warehouse or something, which is probably pretty common if you're doing massive amounts of data changes. It's pretty rare in a transactional environment that you would go update 50 million rows, but we'll come to that. But you can see here that this is a cool idea where you actually leave the original data in place, you clone and change the data, and then simply change the view to point to it. The reason, even if you had an online transaction environment that needed to do this and you had some way of tracking the changes between table T1 whilst you're maintaining table T2, etc. One of the issues with doing this in a high volume transaction environment would be the fact that I effectively ran this table and then dynamically changed the view means cursors get flushed out of the shared pool or get marked invalid. So the two queries I had there were basically a count status C1, that was the first ref cursor I opened against T1, and count status C2, and that was the second ref cursor I opened up against after the data maintenance has been finished. I can only see one of them in the library cache. That's a bit strange, isn't it? And the reason is the first one got marked, has been chucked away because it's invalid the moment I redirected that view definition. To see that data, I need to go look in VLSQL stats, which has a larger retention period. And we see actually what's actually gone on here. This was the query that opened up against user data when it pointed at T1. The moment I recreated the view, that cursor got marked invalid. So effectively, I can no longer use it. Therefore, I had to reparse. In fact, I would have had to reparse even if I used the same query. I used a different column alias so we could see the difference. This one doesn't have any invalidations yet. The next time I do data maintenance, I would copy T2 back to T1, and then I'd do the maintenance in T1 and then flick the view backwards that way. But once again, you can see doing these things where we dynamically change the view definition results in cursor invalidations. And they're generally a bad thing in an OLTP environment because what you don't want is lots of parsing overheads going on. I've spoken many times before on previous videos about the costs of parsing. So for data warehouse, this is a perfectly adequate solution. It's generally going to be fairly read-only data. Parsing costs are negligible in a data warehouse because you don't have a high volume of queries. But if we are in a transactional environment, can we avoid even the parsing overhead? Yes, we can. I'm going to create a context first. A context is just like a little in-memory data store. To set a context variable, you need to bind it to some sort of PL/SQL package. So I'll do that now. I've got a package called pkg, and all it does is set a variable. And the package body simply does dbms session set context, the name of my context, some particular key, and then some particular value. It's only got one key. I'm just going to call it the version. And version sort of suggests actually what I'm going to do here with my data. Rather than have a view that I have to change the definition for, I'm going to create a view that has a constant definition. It's user data, where it gets all the data from T1 only if my version from my context variable is 1. I'm using actually a string here because context variables are always characters. So even though I'm using version 1, it's actually a string. Then select from T2 if the version is 2. So my view always accesses actually both tables. Let's set the version to 1 and run a query. And I get the original version of T1, the unchanged status values. If I set the version to 2, then I get the second query effectively, both from user data, but I get no values of status because they've all been set to null. So simply by toggling the value of this context, which can be a global context as we show in the definition, which means everyone sees the same value by default, I can now flick effectively what side of the union all people are seeing without having to change the view data itself. If I go look now in validations, I can see this is the query I ran now, which is C3. It's the latest of the queries, and there are no invalidations, even though I flicked the version over from 1 to 2. It's one copy of the cursor in memory. It hasn't been invalidated, and yet I can toggle which data people see, the pre or post data maintenance. That's all well and good. It sounds fantastic, but I've now got a view which is accessing both tables, correct? Which means the cost of reading that table is probably going to be double. Let's explore that. Here's the execution plan for, let me pause up a bit, select count status from user data where owner equals sys. It looks like this. It looks like we're accessing both tables because I'm accessing T1 and I'm accessing T2 as well. But the key thing here is the filter lines, 4 and 7. If we go look at the notes to see what actually is going on there, we're doing syscontext var equals 1 and syscontext var equals 2. So the first thing before I even think about accessing T1 is I check the context. If the context isn't 1, I simply bypass this entire chunk of the execution plan. So I won't even touch T1. If the version is 2, I'll only access this part. So even though both tables are listed in there, we will only ever query one half of the union all. Now you might be a little bit cynical of that. An execution plan is a little bit more than not guarantee that this is actually what's going to happen. So let's do this. My current version is 2. I'm going to move table T1 to a table space called demo and take that table space offline. So now T1 is by definition inaccessible. It can't be accessed. Yet what happens now? What if I try run my user data view, which accesses T1 and T2? That's fine. The version is set to 2. We don't even look at the T1 reference. We only access the T2 part. Let's bring that table space back online. So hopefully that makes sense. Let me have a quick look at the Q&A. People want test scripts to run our environment. Yes, I do my best to put most of these up on GitHub. I've only just started doing that because what's the term I'm looking for? I've been lazy in the past. So yeah, I'm trying to put these scripts up now on GitHub so people can use them. And the question was, what's the version of my database? This is running on 19, but nothing you see here wouldn't run on 18, 12, 11, possibly even 10. Nothing here is scary technology. Okie dokie. Sorry, let me mark those questions as answered. Otherwise, they'll keep popping up. Okay, and let's go back to our slides. So, wrapping all that into too long didn't read. One is, you've got to be aware if you're using any kind of truncate or drop commands to do data maintenance of ORA 8103. And the reason I say beware is sometimes you won't see them. They can be sporadic. If the segment happens to be left in place, then sometimes, in particular, like if you drop a petition, often a query can still run off that petition, even though it's been dropped or exchanged. Oracle can be pretty smart that way. Therefore, these become sporadic, which is probably even worse. Using the view concept where you dynamically change the definition of the view is probably going to be fine for data warehouses because we don't really care about the parsing costs and the volume of query transactions is fairly low. But if you're in a high activity environment, then yeah, look at using a context or a table for OLTP. And I totally concede here, I've very much glossed over the fact that if you are going to have two copies of the data, you might need some mechanism to keep them in sync during the maintenance. Just something to be worthy of note. But yeah, I've leave that for as a reader exercise. Okay, number one done. How do we get to 9:30? Oh no. Oh well. This one's a quick one. Standard edition 2, or I would just call it standard edition now because it's pretty much the only standard edition that we offer. I've been reading the various frequently asked questions and license documents that say that standard edition is limited to 16 threads. My server has 2 sockets, but each socket has 32 cores. 32 cores! Am I allowed to run standard edition on this machine? Okay, when we're talking licensing, rule number 1, this is an office hours session, which means I don't work for the legal department inside Oracle. I don't work for the licensing department at Oracle. Therefore, take everything here not as a cast iron guarantee. It is literally my thoughts, which leads to rule number 2. Whenever it comes to licensing, and this isn't just about standard edition, I cannot stress enough to you, you reach out to your local Oracle account manager. That's not me trying to just fob you off. The reason that is so critical is if you ever have any questions or queries or concerns about licensing, purchasing, etc., by having that person involved in a conversation, you've then got them on your side. They're going to be your champion when they go to the broader Oracle organization. But also, they're going to be the person that's going to be able to give you the cast iron guarantees and things in writing. They're going to protect you if there's ever any confusion about licensing costs, etc. Having those guarantees protects you, the customer, and obviously protects Oracle's interests as well, such that everyone's on the same page. So with those 2 rules in mind, I'll give you my interpretation. On any version of standard edition I've ever seen, on this machine or on bigger machines, etc., my understanding is that what we do is we literally burn into the init.io parameters CPU count of 16. Even if you have more than that, the CPU count will be set to 16. I'm pretty sure you can't go above that. I think you get an error. But even if you could, all I would insist that everyone does is that you set it to 16, because once again, it's a protection to make sure that you and Oracle have a good understanding of the integrity of the licensing rules for standard edition. If you do that, set it to 16, then it doesn't matter how powerful your server is. We will only ever use up to 16 concurrent, effectively threads of processing power. That way, you're covered. So my reading of the documents is, yes, you can run standard edition on pretty much any server. I think it's capped at 2 sockets. I don't think you can go more than 2 sockets. But on those 2 sockets, as sockets get ridiculously powerful and get more and more cores, you're limited to 16, and the database will take care of that itself to make sure that you are protected from a license perspective. I'll do a quick sidebar on that, for example, is people say, oh, well, I don't like that because, 16 cores, 16 threads, I mean, that's going to be a problem because, what if, standard edition has no limits on size in terms of the database. So when the database gets bigger, am I going to have all sorts of problems in terms of CPU overheads, etc.? I'll throw this one little quick demo in. For me, standard edition has never been about processing power because computers are ridiculously fast nowadays. Really, for me, if you're choosing between standard and enterprise edition, I think you want to make that decision based on the features you require. If you require for your business certain core features that are part of the enterprise edition, then enterprise edition is a no-brainer. If you don't need those features, I would be very surprised if you ever reach the limits of the processing power that comes with standard edition. Let me run this little quick demo for you. I ran this as part of a previous talk this week, so I figured I'd run it for you. This is stock standard enterprise edition, but the reason I can use this and say it with some authority that it works for standard edition is because my machine, this machine I have right in front of me, is running Microsoft Windows, it's running 19, and it only has 2 CPUs and there are only 6 core CPUs. So I've only got 12 cores in total. So I'm not even close to what the limits of standard edition are. I'm running 10 consecutive threads, each of them doing 40,000 primary key lookups. And you can see they sat at around 400,000 primary key lookups. I ended up getting about 47,000 in this session. If I go to some of the other sessions, you'll see they all got about 47,000. What does that mean? 10 concurrent sessions, 47,000 each. This $1,000 PC, which is now a few years old, is going to grind out about 500,000 primary key lookups a second. Really? I mean, and you're worried about running out of processing power on standard edition? It's never going to be about processing power. It's always going to be about features. So focus on that, and that's going to best equip you to make decisions on standard versus enterprise edition. Okay. I want to clarify always, see rules 1 and 2. 1 is it's office hours here, not the legal department in Oracle. And number 2 is please always communicate with your local account office for all the cast iron rules and the important legal information that's going to clarify you on licenses. Don't go to anyone who says, I went to Connor's session and he said this, because you know what they're going to say? They're going to say, Connor who? Anyway, let us move on. Scheduler timings. I know that the scheduler has maintenance window. Oh, this is one for the chat line. Is it scheduler or scheduler? Is it shush or sku? I'll go scheduler and see how we go. I know the scheduler has maintenance windows where optimizer jobs and advisors run, etc. But we are seeing these jobs run during the day and it's hurting our performance. Why is this happening? Just a quick bit of background, because I know we're focused on time. A quick bit of background on schedulers, windows, and maintenance jobs. Back in the day, around the Oracle 10G and before, we had a really cool either DBMS job infrastructure, which then became the DBMS scheduler in 10G. But whichever you were using, we had a very cool facility for running things asynchronously in the background at a scheduled point in time. It's cron for the database. And what that was you would then put all the things that we'd told you to do to run at regular intervals, gathering stats, running the advisors, maybe doing database reorganizations, etc. That's all well and good, but a lot of those things are just part and parcel of every DBA's toolkit, or they should be. So come Oracle 11, we introduced this thing called the automatic task management infrastructure. Wasn't particularly well publicized, and we sort of slotted it in there, but what happens was we suddenly said, you don't have to run these common things yourself. We will automatically look after optimizer stats, segment advisors, and storage advisors. And they were part of this thing called the automatic task framework. To enable that, we created these things called scheduler windows, which were already in the scheduler from 10G onwards, which would nominate a time at which you could actually run these things. The database would be given an allowed point in time. By default, it was 10 p.m. till 2 a.m., I think, during the week and most of the weekend. So if you're one of those businesses that did most of your work on the weekend, you probably wanted to change that. But those scheduler windows were put in place to enable the automatic task infrastructure. Here's what my customer sent to me. He said, this is the problem. He said, they're running during the day, but our windows are defined just right. If we look at this query, this came out of SQL Developer, and it says the Monday window starts at 2 a.m. They changed away from the default of 10 p.m., Tuesday at 2 a.m., etc. Saturdays and Sundays started at 11 p.m. So they sent this feedback saying, this is what we've got them set to, yet we're seeing our optimizer jobs run during the day. Let me pop back a sec. That output struck a bit of an odd chord with me. And the reason it did was when I looked at the next start date, the output mask there looks fine for a date, but something bothered me because I'm pretty sure they're not dates in the scheduler. And when I went and looked at DBA scheduler windows, I was right. The various date columns are all defined as timestamp with time zone. So why couldn't I see it in this particular output? And what happened is this customer had edited their NLS settings in their SQL Developer preferences to strip out that stuff because they didn't use time zones anyway. When I asked them to run the same query just in a stock standard SQL Plus session, we see this output. It looks the same, except now we have the time zone information as well, and they're all 2 a.m. in the US Mountain Time Zone, which was fun until I said, do you live in the United States and do you live near a mountain? And they said no, they were coming to me from India, and therefore something was a little bit afoot. That's why their schedules were running not at the middle of the night. They're running in the US middle of the night, which doesn't happen to be the middle of the night in this part of the world. The most common cause for this is when we create databases, especially if we're creating them for the first time, is often we'll do something like this. We'll simply grab the database configuration assistant, and we'll use the database that copies the data files that are already present inside the DBA templates. Most of them were built in the US, and things like sysdate and stuff come from your OS, but things that are burnt into the database itself will come with what's in those data files, which will be US Mountain. So let's do a little demo on how we would fix it. Just to prove what's going on here, I've got select sys timestamp from Jill. You can see this is in my time zone. I'm Greenwich Mean Time +8. That's we're 8 hours ahead of England in Perth here, and it's 9:38 p.m. my time. If I create a job that does nothing, so the job is literally called does nothing, and I say I want to start at sys timestamp, that's the start date, all looks well. It says, yes, it's going to start at 9:38, and the next day will be 9:38, etc., tomorrow, etc. So all that looks fine. So your typical usage where you've nominated the start date all seems to be work, and you don't seem to encounter this problem. However, let me drop that job and recreate it now with something that's just as valid, which is the start date doesn't have to be specified. It will default. If I let it default, we start this thing. We start seeing this anomaly. The start date is now 7:38 a.m. US Mountain Time, which is right now, but it's all now been stored in terms of a US time zone, which means it will have an alternate description if we're looking at scheduler windows. That's strange though, because how did it find this US time zone? Because my time zone on my computer here is obviously Perth time. The scheduler has its own time zone that is set inside the scheduler, and you can see it by running dbms scheduler stime from Joule. And it says the time zone we are using inside the scheduler, which will be used by default if you don't nominate time zones when you create things, is US Mountain. How do we change it? Very, very simply, and I would imagine that this is something you probably want to do if your scheduler time zone does not marry up to your database time zone or your own operating system. You simply set the default time zone attribute to your time zone. In my case, it's Australia Perth. I'll drop the job, recreate it now with no start date, so I use the default, and you see now it picks up the schedule a default time zone of Australia Perth. So that's a quick demo and a very simple fix, just something to be aware of, because we often think that, well, if we have the OS set correctly, then the database will just pick up everything from the OS. That is not entirely true, because we have the OS time zone, we have the database time zone, and we also have the scheduler time zone as well. And it would generally make sense to bring them all into alignment. Probably the only exception to that would be is if you're running a database with global customers all over the place. A common thing I see is people set their database time zone to being UTC, and everyone then uses time zones to get their correct local time. Obviously, the key thing is check your defaults, make sure that basically your defaults are set correctly. And I think in all cases, really, this is just a special case of those kind of things where often we assume the date string for a date format, or we assume the number string, etc. We assume that the database will take care of data type conversions for us. The best practice has always been, whenever you're dealing with dates, time zones, numbers, anything like that, be explicit. Use the toDate functions, the toTimestamp functions, the toTimestamp TZ functions, etc., to explicitly nominate the times and time zones. Okay, the Hacken factor. We're getting through some of this stuff. We're doing pretty well. We have been using your clustering attribute technique to sort our data to improve query performance, but with our workflow tables, this creates a storage growth issue. Do we have to incur this penalty? My clustering attribute technique is where we add the clustering attribute table and resort the data. But so let me describe the issue first with some graphics, and then we'll talk about how we're going to fix it. When it comes to workflow tables are often a problematic object inside any database, because what happens is workflow normally means a table or piece of data goes through various iterations of attributes. So I've invented this fictional one, but it'll hopefully describe what I mean by a workflow style table. This is similar to what the customer have, obviously with a real example. I have a table called online orders, and so when an order comes in, these are the pieces of information we know. We know when the order was created, we know who the owner of that order is, and we know what they've ordered. In this case, they've ordered a phone, an iPad, or a TV, etc. That's the first part of workflow. Once that sale has been requested, now we have to act on it. So what happens is we add more data to it. Now, these columns obviously already exist in the table. They're just all null when we first create the order. But what happens now is, as we come along, when someone picks up that order inside my organization, it's initiated on a certain date, it's initiated by maybe some sort of employee number, and then we nominate where those products or those items are going to come from. One's coming from the Sydney warehouse, one's coming from the Singapore warehouse, and this third order is yet to be started. And then orders get worked on and processed and put in boxes and get ready to be shipped, etc. And so eventually they get dispatched. And so these top two orders, once again, get more data. As of before, all these columns already existed. We don't add columns to tables just to add data. They already existed, but they were all null, and now we've updated the dispatch date because it's been sent off, and we're saying who it was, FedEx, etc. Workflow tables have a common characteristic of that they start as small rows, and the rows get larger and larger and larger. Quick Q&A here. Someone's saying, not a question. I'm in the UK and I'm looking at you from the future. There we go. The problem with rows that grow over time is that we have to deal with them in some way or shape or form to ensure we have good performance, because this is what happens internally. And this is a very quick recap of something we've already seen in a previous video of mine in terms of percent free, percent used, etc. I insert some rows and they go into a block. And so here's the row, it's small and compact, and lots of small rows go into that block. When I update that row, I'm making the row bigger, so it can't go straight back into where it was, especially if it's surrounded by other rows. And so we can't do that. So the row goes into percent free. Now, just because of bad PowerPoint skills here, it's not like broken up into two chunks. The entire row would be moved into that percent free area. I'm just terrible. I didn't want to make it so small that we couldn't read it. So it looks like it's been split into two there, but it's not. It's the same row. It's just been relocated into the percent free area such that the whole row can sit together. But of course, that's just the first part of the workflow. When we then update it and make it even larger, eventually we run out of percent free space entirely. We can't fit those extra two columns into that full block anymore. And the reason they get full so fast, even with percent free, is because every single row is starting small and growing over time. So what do we do? As we've seen in previous videos, we have to migrate that row to a different block, or a new block preferably, probably where it will fit all the columns all in one chunk, and we leave a forwarding address, which kills us in terms of index access performance. We can solve this just by obviously increasing the percent free to make sure that as all those workflow changes occur, it's still going to fit in the same block. So I might choose percent free of 50 because I know that the rows are going to grow by, say, 50% in size. This solves that problem because I start off with just a few columns populated. As I update, it goes into the percent free area. As I update, it still fits in that same block. I've eliminated the migration issue by simply making a large enough percent free to handle the fact that my rows are going to grow and grow and grow. The drama comes for when you want to do any kind of data maintenance. If I've done this well by using, say, percent free 50, almost all the rows are going to grow to fully populated because at that point my products have been shipped. So here's a typical looking block. The vast majority of rows are now all fully padded out, and there's a few in there. This one's sort of, it's half being processed. And here's a couple of small rows here that have yet to be even have any kind of extra workflow done to them. But the vast majority, you'd imagine, orders come to a close after time, will be like this. And so our data is going to be nicely packed. This person said, that's great, but I'm trying to reshuffle my data to use some linear attribute clustering, which gets you some great index benefits. I've done a previous video on that. You can find that on my channel. You add linear clustering and then you do alter table move to reshuffle the data, to clump it in the particular clustering order you like. But the table is percent free 50. That's a problem because when you do alter table move, we respect percent free 50. So now all my blocks, yes, they've been nicely reshuffled in terms of linear cluster attributes, but I've now got 50% free space in every single block. And as I said, the vast majority of these rows are never going to grow anymore because they're done. They've grown to their maximum size. So I got this thing where now the table has a lot of empty free space in it. New orders will eventually come in and fill this up, but while that's going on, my table is going to sit typically at about double the size it needs to. All those benefits I was aiming for with linear attribute clustering perhaps aren't going to be realized now because my table is actually twice as big as it needs to be anyway. Ideally, what we're going to do is don't move the full ones. If the rows are filled up to their logical size, then let's not reshuffle them. Don't move them, or at least don't leave those blocks half empty. That's what comes into what we call the hacken factor as a technique to do this. Funnily enough, the hacken factor actually has nothing to do with percent free and clustering, this particular issue we're talking about. The hacken factor is actually all about dealing with bitmap indexes. So a little bit of background explaining what the hacken factor is and why we have it, and then we'll circle back to why it's going to be useful here. Bitmap indexes, as people know, are generally used for when you have very low numbers of distinct values and you want to get some good indexing benefits where a B-tree index might not help. Without jumping into a full-length expose of how bitmap indexes work, ultimately the elements that go into the bitmap index blocks look like this. We have a key, a start and ending row ID pair, and then a number of bits. Now, to help explain why it is like this, let's expand upon this. A common, very low distinct number of values entry might be gender, male, female, unspecified, maybe 3, 4, 5 distinct values across a very large table. So I might use a bitmap index. For each key, in this case, I'll tick one key of male, The way the bitmap index works is we pick a range of blocks. So we have a start row ID and an end row ID, which indicates a range of blocks. I've picked 4 here. Inside those 4 blocks, obviously, some of those rows are going to have a value of male. The way the bitmap index works, hence the term bitmap, is to indicate within, where's my mouse gone? Within these 4 blocks in which row positions are males, we store a bit string. So first row was not male, second row was not male, third row was, etc., etc., etc. So please don't score me on whether those bits actually map to those entries. It's close enough to hopefully give the example. So that's roughly what each bitmap block entry looks like. The question is, why did I choose 4 blocks? Why wouldn't I choose maybe 8 blocks and just have a longer bitmap string? And I can. There is a limit to how many bits we can store because an index leaf block is itself limited to the size of a block. Obviously, the more bits we can store and the greater range of blocks we can cover, generally the more compact our bitmap index will be. But it's limited obviously by the length that this bit string can be and still fit into a leaf block. Ideally though, maybe 8 blocks would be better. The reason we have to make a decision here on whether we use 4 or 8 is we need to know how many rows could possibly be in 8 blocks. Now, how do we do that? If the table is empty and I create a bitmap index on it, well, I've got no data to work with. I actually have to sort of just assume what's the worst case scenario. And maybe I could assume maybe 4,000 rows in a block. That many rows means a lot of bits I have to store even for a small amount of blocks. I could probably choose 8 blocks if I had this many rows per block. What's that? 6, 7 rows per block. But if I had this many, maybe I have to drop down to 6 blocks per key or 4 blocks. The number of rows that could potentially fit in a block is critical to determining how many blocks I have in each range, which limits to how many bits I have to store. So the Hacken factor is a number that stores the maximum possible rows on a single block for a given table. Why could this be useful for us? If I could nominate what the maximum number of rows I'm allowed to have in a single block is, that becomes useful when it comes back to my workflow table. Because in this case, if I said 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I'm only allowed to have 10 rows in a block, even if they're little small rows like this, they're the brand new orders. Then when those rows grow, they will fill the block and I won't have any more dramas. Effectively, it's a different version of insisting upon some free space in a block. Let's look at the Hacken factor now to do a demo of that. What have we got? 7 minutes left? Well, I think we might get this demo done. It suddenly dawned on me that, of course, that we have another topic to cover, but that's going to go in the next months. Okay, here's my online sales table. I've been lazy here. I've just invented a whole stack of columns and really just 2 columns that are fairly large. These are going to be the 2 columns that simulate us going from thin rows to fat rows in terms of a workflow style of operation. So I'm going to start off with some simple orders, which are initial orders. So there's nothing for the status, nothing for the process. They're all just the first, what's that, 7? The first 7 rows. Let's try that sentence from the top. The first 7 columns have been populated and the last 2 are null. I'm using compute statistics here as opposed to DBMS stats, not because I like analyze, but this is the only one that still gets us the chain count column in user tables. By default, after a simple insert, my chain count is 0. My table is 622 blocks. Now let's do some workflow. I'm going to make those rows bigger by populating the state column to processed, and the invoice number becomes my invoice number. I've just made every single row larger. Compute statistics, and we initially see what the problem is if we don't allow enough % free. My table has grown, but that's expected. I've actually made each row bigger. But notice out of my 100,000 rows, almost half, or just maybe between a third and half of them have now been migrated because they no longer fit. Every index access to those 38,000 rows will now incur a performance penalty. I didn't choose a good percent free for this table. So let's truncate it and repeat the demo as we saw on the slides with a better percent free. I'll make it percent free 50 to allow plenty of space. I insert my brand new orders once again without the state and invoice number populated. This is the start of the workflow. Now I'll go ahead and update all those rows and make them larger, the thing that caused all the migration first time round. Compute statistics, fantastic. The table blocks have grown, but my chain count is 0. I chose an appropriate percent free such that all the rows could grow and not have to be migrated. If this was all the demo was doing, I'd be happy. I'd be happy with this. But as I said, this customer wanted to do the occasional alter table move. Not just a move in isolation. They wanted to do some clustered attribute clustering, but in this case, I'm just moving the table. Because percent free is 50, I compute statistics. Yes, my chain count is still 0, which is great, but my table's gone from 1,000 blocks to 1,655 blocks. It's now almost, 40% of empty space. That will slowly over time be refilled again with new entries, but it's going to take time, and any kind of analysis like full table scans are going to incur a performance penalty until that occurs. So let's now truncate it. Let's set percent free 1, because I'm not going to worry about percent free anymore. As we said, to calculate the Hacken factor, the database wants to know the theoretical maximum number of rows to put in a block. I can actually force that number onto the database by doing the following. I'm going to populate enough data in the table to at least fill one block. This fills up a few, but doesn't matter, as long as I fill up one. And I've fully populated the rows. So these are random samples of, just basically garbage data, but they'll be fully populated rows. They're an indication of how big the rows will ever get. And then I run this command. I hate this command because I hate the word records because I like the term rows, but alter table online sales, minimize records per block. Counterintuitively, what that is saying is work out the maximum number of rows I can find in any block, and that is going to be my hard limit from now on. It's ideal for creating compact bitmap indexes, but we don't care about that. We care about the fact that the database now has stored an upper limit on the number of rows that can go on each block in this table. I truncate my garbage data out and now do it in the normal, genuine data fashion. I insert my rows with the 2 nulls at the end, so they're workflow initiation. I compute statistics. I'm at 1,000 blocks with a chain count of 0. Notice the 1,000 blocks is roughly the same as what we had when we had percent free 50. The database has refused to let those small rows fill up blocks. It's spread them out. I update all my rows and make them all larger. I compute statistics, and I'm still at 1,000 blocks, and my chain count is 0. This is the same as when we had percent free 50. I've managed to fill in all that blank space in those existing 1,000 blocks. But now when I alter table move, compute statistics, the chain count is 0, the number of blocks has not gone up, the database has just been effectively moved in situ. I haven't had that growth. I haven't had to diddle percent free numbers, etc. The database now knows that for this table, I'm only allowed an upper limit of this many certain rows per block. Sadly, can you see the Hacken factor in the data dictionary? Not by default. Is it actually stored on the tab $ internal dictionary table that sits underneath DBA tables? It's in the column called spare 1, encrypted in a certain way. That's all I'll probably be prepared to divulge, but you can find it out. Google will help you out there. But yes, it's unfortunately not exposed as a genuine column in the data dictionary. So I think the Hacken factor is a cool option because we're thinking outside the box here. We're not using it for bitmap indexes. We're using it to satisfy another problem, a very common problem, and that is rows that grow over time in a workflow style arrangement. Because we're using it outside the box, I would stress whenever you're using a feature of Oracle that it wasn't perhaps originally intended for, be aware that probably means it wasn't as thoroughly tested as for its core use case, simply because not as many customers around the world I will be using it for that facility. Instead of 100,000 people testing it, you've probably got 1,000 people testing it. So always check your own usage to make sure that you don't encounter any boundary cases, etc. For example, what if you're doing the hacken factor on a partition table? Each partition could have different row kind of length characteristics. There are interesting things to be aware of when it comes to calculating the hacken factor. We are done. We didn't get to our last one, which is the concurrency versus high volume stuff, but that will be a very interesting topic for next month's office hours. As always, thank you very much for your attendance. As I said, it is 10 p.m. Don't go anywhere. Jump out of this Zoom session, leap over to the Apex one for all the new features coming in. I'm sure it'll be a fantastic session. But as always, hopefully you enjoyed this session. Hopefully you found some very interesting stuff. I've got one last Q&A. That is correct. Hemant's saying, yes, you can't migrate a hacken factor from one table to another. Yes, it's stored internally. In theory, you could with some nasty hacks, but don't blame me when you're no longer supported. As always, thank you very much for your time. I know you're being snowed under with webinar after webinar after webinar. I appreciate your patience. I appreciate your enthusiasm for Oracle technology. And we'll see you hopefully soon on one of the webinars I'm doing in the next few weeks, if not next month on office hours. Bye for now, everybody. Have a great evening, morning, or afternoon.